Okay, so today we'll continue with that. Okay, so kita dah tengok ini, so we already know how to use the DDRX. Now we're going to see what is the PINX register. Okay, so as you already know, okay, as you already learned that for each of the port we have 3 register that you need to know which one that is DDRX register, PINX register, and PORTX register. Okay, for the DDRX, you already learned that the DDRX is used to determine either you want going to make your port as an input or as an output by sending the 0 or 1 to your DDRX register. So now we're going to see what the PINX do. Okay, so PINX register is used to read the data at the AVR pin or legs. Okay, so every time you want to read a data from your input, for example from your switch, you're going to use this PINX register, okay, to store the data from the outside, from your input to your CPU. Okay, so this PINX register, okay, will bring the data into your CPU from your pins, okay, which is from your AVR pin, or sometimes we can call it as a AVR legs, okay, kaki AVR tu, okay, to read the data, okay, to bring the data to the CPU, we are going to use the PINX register. Okay, so this is the what we call this example lah. Okay, you have the this is your contoh lah. I give you a contoh kat sini. Sekejap ya. Okay, so semua dapat tengok tak this one? Alright, so this contoh lah. Okay, so this is your AVR. Sorry, my drawing tak cantik. Okay, so AVR you have total of number of pin is 40. Okay, let's say lah kita ambil this port A here. This is your port A. Okay, so this is the pin lah. Okay, starting from PA0 to pin A7. Okay, so let's say lah, now this one here you are going to connect to your switch. Okay, so each of this pin here kamu sambung pada switches. Okay, so this is an active low switch lah. Okay, so this is an active low switches. Okay, so before you're going to read this switches value, okay, and send it to your CPU, which is inside of your AVR here, what you're going to do is you need to initialize this port A so that this port A become an input port. How to make your port A as an input port? So you're going to use the DDR A register lah. Okay, make sure that the DDR A register you make it you send 0. Okay, since this port A here, dekat semua all this pin here, you connected to switch, so you make the whole port A kat sini sebagai input. Okay, so how to do that? Okay, by doing a programming. Okay, load I R16 0 and out. Sorry, DDRA R16. So what happened is automatically port A sekarang sudah jadi input. Okay. So now what you're going to do is, okay, after you initialize this port A sebagai input because you connecting them to the switches. So now you're going to take the value of this switch lah, either it is press or not press. Okay, for example lah, because this is an active low punya switch, because you connected to the ground. So whenever you press the switch, what happen is it will give 0. Okay, when press, dia akan jadi 0, and when you release it, the switch it become 1. Okay, let's say lah, we give this one 1 0 1 1 0 0 1 1. This is the input that you're going to send to your CPU. So what you're going to do now is, okay, to read this input here from your switch here, what you're going to do is you need to use the PINX register. Okay, kamu kena pakai PINX, pin A register to read all the input from these switches. Okay, so now what you're going to do is you just put something like this in. Okay, kita pakailah R17 pin A. Means that any value which is that coming from the switches here will go to your pin A. Any value that go to your pin A will be stored to your R17. Okay, so what happened here kat sini? Okay, so this one here. Okay, so kat sini apa yang berlaku? Okay, so this is your register. Okay, so this is your DDR register. This is your pin A register, and this is your port A register. Okay, since this one here, you make it as a 0 0 0 0 0 0 0, so you know that this pin or this leg of your AVR now become all inputs. Kan jadi inputs kat sini. Okay, this is your PA0 and this is your PA7 lah. Okay, so now you give this value here. Okay, so this is the value of the switches. Okay, that you give at your port A punya pin out. Okay, so what happen is, since this one here, all of this here is input, so this number here, okay, this value here will go to your pin A register kat sini. So dia akan jadi 0 1 1 0 0 1 1. So this is the number that inside of your pin A. What about port A? Port A, the value still 0 lah. Okay, nothing. Tak ada apa-apa yang berlaku dekat you punya port A. Why? Because the port A is used as a output, okay, to send out the data from CPU to the outside. While the pin A register is used to read the data from your input, okay, so that you can send it to your CPU. Okay, so what happened here is, since your pin A here, this is the value of your pin A, so when you put something like this in R17 pin A, what happened is R17 akan ada value pin A, will have the pin A value which is 1011 0011. Okay, this is what the PINX register do lah. Okay, so any question? Up? Ada soalan tak? For this one. Yes, pin A get the data from the input only. Okay, the PINX register or pin A register will get the data from your input, which is your switches lah. Okay, if you connect your port to your switches. Okay, if no question, then okay, any other function for the pins? No other function except that the pin is used to read the data from your input. That's all. Okay. You mean the AVR pin or the pins register? Okay, so if no question, then we go to the next slide. Okay, your friend here, Tan Wei Fang, asked me, is it any different from the AVR pin and pin register? Yes, there are two different things. Okay, the AVR pin is your AVR punya legs lah, dia punya kaki. While the pin register, PINX register is the register inside of your AVR. Okay, so there are two different things. Tak sama. Okay, AVR pins and PINX register. Okay, next we go to the PORTX register. Okay, so the PORTX register is used to send the data out to the AVR pin and legs. Okay, so whenever you're going to send the data out from the CPU to your output, so we use the AVR pin or legs. Alright, so this one, yeah. So let's look at the example. Okay, the same example I showed earlier. Okay, kat sini mana tadi saya punya slide tadi. Okay, so I need to switch back this one. Okay, so we take the same here. Okay, so let's say lah this is your port A, B, C, and this. Let's say lah this is your port D, for example. Okay. So again, your port D has 8 pin ataupun 8 legs, ada 8 kaki kat situ, which is labeled by PD7 to PD0. Okay, so now what happens is all of this port D here, you are connected to your LED. Kamu sambung this one here to LED. So let's positive, negative. So this one is communicated punya LEDs. Okay, so you draw lah. Okay, so now you're going to send the value, right? Since okay, from CPU to lights up this LED. Contoh lah, okay, the value that's from the CPU that you're going to set is 1111000. Okay, since this is a common cathode, okay, so ingat lagi tak what is a common cathode? Okay, this is your micro P. Okay, and then this is a common cathode. When you put 1 here, what happened to your LED? When you give 1 to from your micro P, apa yang berlaku pada you punya LEDs? Is it your LED turn on or turn off? Okay, when you give 1, what happens is, okay, because this is high, if the current will flow from high to low. So means that this one here will turn on. Okay, kalau you give zeros, okay, you put 0 here, what happens? Because this is 0, the ground also 0, so the current cannot flow, so this one will turn off. Okay, so now what happens is, you're going to make, okay, the first LEDs here off, and the next 4 LED turn on. Okay, so what you're going to do here is, mula-mula, okay, we need to configure lah this port D here, so that this port D become an output port. How to configure our port D so that the port D become output? So we need to make sure that, okay, since this is a port D, so In order to make the port D as an output port, so we need to, okay, to make our DDRD, okay, we need to give 1 to our DDRD so that our port D kat sini become output port. Okay, so how to do that? You by doing by writing the program lah. So LDI R18 for example, OX FF. Ataupun, okay, you can put LDI R18. Okay, this is the same thing lah, benda yang sama. Okay, so you make all the legs here, all the pin, the AVR pin the port D as a output port by sending 1 to your DDRD. Okay, next what you're going to do, out DDRD R18. What happened here? After you execute this instruction here, your port D become output. Okay, dia akan jadi output port. Okay, now we are going to send this value here. Okay, so that LED from PD7 to PD5 is turned on, while LED PD4 to PD0 is turned off. Okay, so something like this lah. So this is your LED that are connected to your port D punya pin out. Okay, so this is a PD7 and this is PD0. Okay, so you're going to send this value here. So how to send this value here from CPU to the output? So by using the out instruction, out, okay, port D R. Okay, before that, sebelum tu, okay, before you send it out the value, okay, you need to make sure that this value here you already load to your register first. Okay, so LDI R19 for example, what value that you going to send, which is this value here, 0B lah, kita pakai binary 11110000, and then out port B R90. So what happened? So this LED akan turn on, while the rest of the LEDs will turn off. Okay. Any question? Okay, so one of your friend here, okay, can you ask, please do not ask privately. You can send the message to everyone, okay, so that your friend also can see what you're going to ask, or you can simply ask me you can just speak to me. Okay, boleh somebody try to speak tak? Whether I can see your voice or not? Whether I can hear your voice or not?
Okay, sir.
Yeah.
May I ask how do we determine which register number to use, like R18, R16, R19? How do we determine the number?
Okay, so since okay, we have total of 32 register from R0 to R31. Okay, you can use any of this register. Okay, you can use R20, you can use R25, no problem. You are determine which register that you're going to use.
Okay, sir. So it acts like a variable.
Yeah, it's like a variable in the C programming. Betul.
Okay, okay. Okay, thank you, sir.
Okay, welcome. Okay, one of your friend asks, can straight use out port B with the value? Cannot. Okay, why cannot? Later we will see the syntax of that instruction. Okay, you need to follow the syntax of that instruction. If not, you will have, if you compile the instruction, then the that instruction will give you an error. Okay, we need to follow the syntax. Okay, now let's look at the AVR architecture. Okay, so we already learned that. Okay, so in order to make a complete system, okay, you need to have a CPU, memory, and the I/O. Okay, so this all the CPU, your microprocessor, you put inside of this chip here, and then you have a memory here, RAM, program memory, EEPROM. You also put into your IC, and then you have the I/O peripheral you put inside your IC. Then you have a complete computer system. Okay, so let's look at the AVR architecture. The AVR architecture has three main memory space. Okay, there are tiga memory space that you need to know. The first one we call it as a program memory. Okay, so as I mentioned in the previous class, the program memory, or sometimes we call it as a flash memory, used to store your program. Okay, every time you write down your program, all of those programs will be stored inside of this program memory. Okay, then we have the data memory. Okay, so the data memory used for to store the data. Okay, so since your data memory is inside of your RAM, okay, so this is a temporary storage data lah. Okay, you only can store the data temporarily. Okay, then we have another store memory called EEPROM. Okay, so this is another memory to store the data. Okay, so you have a three memory here: program memory, RAM, and EEPROM. But in this AVR, in this course, we only focus on these two: program memory and then RAM. Okay, so this is your CPU lah. Of course lah, you have a CPU, you have the memory, and then you have the input-output peripherals, so that you can make a complete computer system. Okay, so AVR use hardware architecture. We already know that. What is the hardware architecture? That has a separate bus for the code or for the program and the data memory. Okay, so we already learned that in the previous class. Okay, the program memory and data memory are, okay, this is your program memory and this is your data memory are separated, which is they have their own buses. Okay, there are two kinds of buses in AVR. Okay, the first one we call it as a program bus. Okay, which is this program bus here to provide an access to program, flash, and ROM. Okay, which is this program bus is used to communicate between your CPU to your program memory lah. Okay, while you have another bus called a data bus. Okay, which is to communicate between your memory as well as your I/O with your CPU. Okay. Okay, so this is the overview of AVR architecture. Okay, so again, your what we call here, your AVR memory can be divided into three parts. Okay, kita boleh bahagikan kepada tiga bahagian, which is, okay, so this is your flash ataupun kita panggil dia sebagai program memory. So this is your program memory, which is the starting address of your program memory starting from 000 until Fn. Okay, this is Fn. What is a Fn? Your end address of your program memory. How to know your Fn? by looking at this table here. Okay, kamu kena tengok pada table ini. Because why? Because the Fn here will be determined by the size of your memory. Okay, for example, we take ATmega 32. Okay, since your ATmega 32, the program memory or your flash memory is 32 kilobyte size. So the end address here will be 3FFF. Okay, so later we will learn how to do a calculation in order to get this end address. Okay, nanti kita akan belajar how to find, well, based on the size of your memory, how to obtain your end address. Okay, next we have the, okay, so this is your first, your program memory, and then we have the second one, we have the EEPROM memory. Okay, so again, your EEPROM memory starting address from 0000, and the end address here for the ATmega 32 is 3FF. Okay, it depending on the size lah. Okay, so this one is 32 kilobyte, and this is 1 kilobyte only. Okay, and then the most important part is your data memory, which is your data memory can be divided to 3 parts. Okay, first we call it as a GPR. Kat sini kita panggil dia sebagai GPR. Okay, you have a 32 general purpose register, which is the start address from 000 to 001F, and then you have the 64 IO register. Okay, kamu ada 64 IO register, which is the address here starting from 0020 to 005F, and your RAM, okay, the size of your RAM here is 2 kilobyte. Okay, so the starting address of your RAM is starting at 0060 until 085F. Okay, so this is your RAM N, the last address of your RAM N for ATmega 32. Okay, and then if you're going to put external RAM, so the external RAM will start at this address here 0860 until, depending on your RAM size lah, your external RAM size. Okay, so this is the memory overview of your AVR architecture. Okay, ada 3 memory, program memory. The first one is program memory. The second one is EEPROM, and the third one is your data memory. Okay, so you need to know the size. Okay, you need to remember this size here. Okay, for ATmega 32, the size of your program memory is 32 kilobyte. RAM is 2 kilobyte, while EEPROM is 1 kilobyte. Okay, so let's look at the AVR program memory or your flash memory. Okay, so we already know that this program memory is used to store your program code. Okay, every time you write down your programming, it will be stored inside of your flash memory or your program memory. Okay, the ATmega 32 contains 32 kilobyte for program storage. Okay, so this program here, this program's memory is organized by 60K multiply 16-bit. Okay, means that the size of this program memory is 16-bit. Okay, so I go to the previous size. Okay, so this is 16-bit. Okay, compared to your data memory, the size here is only 8-bit. Dia punya size kat sini hanyalah 8-bit. EEPROM also, this one is 8-bit. Okay, only the program memory, the size is 16-bit wide. Okay, while the rest data memory and EEPROM, the size is 8-bit wide. Okay, so kena remember that one. Okay, so for the software security, the flash program memory space is divided into 3 sections. Okay, so you can divide this program memory into 3 more sections. Okay, for the first section here, we call it as a reset and interrupt vector section. Okay, so it has a 42 word ataupun 84 bytes. Okay, so total of reset and interrupt vector section is 84 byte kat situ. Okay, which is starting address from 000 until 0029. Okay, then you have an application program section. Okay, so this is where you store your program. Okay, which is starting from address 002A until 3C00. Okay, and the last one here, this is reserved for boot program. Okay, section which is 1024 word. Okay, starting from 3C00 until 3FFF. Okay, so every time you write down your program, all of the program will be stored here. Okay, you cannot store your program here because okay, and here tak boleh letak kat sini, neither this one. Okay, because this is the dedicated. Okay, you only can store your program inside of this section here, dekat tengah-tengah ni. Okay, next we go to the EEPROM. Okay, so the Atmega32 contain of 1 kilobyte of data EEPROM memory. Okay, the size of your EEPROM is 1 kilobyte. Okay, it is organized as a separate data space in which single byte can be read and written. Different chip have different size of EEPROM memory lah, of course lah. Okay, so this is for Atmega32, mana Atmega32. Okay, so this is your Atmega32. Okay, the size of your EEPROM is 1024 byte, which is equivalent to 1 kilobyte. Okay, and then last but not least is your AVR data memory. Okay, so the data memory in AVR can be composed of 3 types of register. Okay, the first one we call it as general purpose register. Okay, so this is your GPR lah. Okay, your GPR, the total number of GPR is 32, which is from R0 to R31. So every time you see the word R here, means that this is belong to your general purpose register. Okay, then you have a IO register. Okay, total number of IO register is 64. And the last but not least is your internal data of your SRAM. Okay, so this is your RAM lah. Because here you have a RAM. This is your GPR. And this is your IO. Okay, so let's look detail on these 3 registers here. Okay, let's look at the GPR first. Okay, so GPR, general purpose register. Okay, so this AVR microcontroller have many registers for arithmetic and logic operation. So this general purpose register is used for arithmetic and logic operation as well as to temporarily store your data. Okay, in the CPU, registers are used to store information temporarily. Okay, every time you see the word register means that you're going to store that information temporarily. Okay, it's like a variable in your C program. Okay, that information could be either you're going to store a data you're going to process, or you're going to store an address. Okay, so this register can store the information such as a data you're going to process, also the address that you're going to fetch. Okay, so the majority of AVR register is 8-bit register because in AVR only one data type which is 8-bit. Okay, so that's why lah you punya data memory. Okay, if you see here, the data memory here is 8-bit wide, 8-bit dia punya size. Okay. Okay, with an 8-bit data type, any data larger than 8-bit must be broken into 8-bit chunks before it is processed. Okay, contoh lah, if you have the 16-bit data, okay, you need to break it to 8-bit data and then another 8-bit data. So you need to send the first 8-bit data and then followed by the second 8-bit data. Okay. So in AVR, there are total of 32 general purpose register. Ada 32 general purpose register. Okay, this general purpose register is what we call here is labeled by R0. Okay, this is starting from R0 to R31 and are located in the lowest location of the memory address. Okay, what is the lowest location of memory address? Can someone tell me what is the lowest location of memory address? Anyone? Not 1F. Okay, the lowest location means that it started at address 0000. This is the lowest location of memory address. Okay, so your R0, you see here your R0, the address of your R0 is 0000, R1 is 0001, R2, the address is 0002, while R31 is the address is 001. Okay. Okay, how to obtain this value? This address value. Okay, so since this is R31, so you just take 31, convert this value here to hexadecimal, then you get the 1F. Okay, the symbol, the dollar sign here represent the hexa number, hexadecimal number. Every time you see the symbol dollar sign kat sini, it is, you know that this value here in hexadecimal number. Okay, because sometimes you will see the dollar symbol inside of your register as well. Okay, not only at the address side, but as well inside of the register itself. Okay, means that this one, the value inside here is the in hexadecimal number. Okay, so this register here is divided into two groups. Okay, the lower register and the upper register. Okay, the lower register starting from R0 to R15, while the upper register starting from R16 to R31. So this is your lower. Okay, so this is your lower register, and this is your upper register. Okay, what are the difference between the lower register and upper register? Okay, the lower register work just the rest of the register with the exception of loading immediate data. Okay, you can use this register, this lower register here, okay, with any instruction, except that the instruction that need you to load immediate value. Okay, while upper register R16 to R31 can access to immediate data using the LDI instruction. Okay, so this one here, okay, is dedicated to access an immediate data. Okay, how to differentiate between the instruction with immediate data and without immediate data? Okay, so LDI, for example. Okay, for LD, can I use R40 for LD? Okay, R40 for LD. Can I use the R40 for LD? Yes, you can use the R40 for RD. What about R30? By using the LD instruction pun boleh. Okay. Next, kita ambil yang di sini pula, LDI instruction. Can I use R40 for LDI instruction? Cannot. Why cannot? Because I. Okay, at the end of this instruction, the I means that immediate value. Every time you see the instruction that ended with the huruf I, means that it involves the immediate data. So you cannot use R14 with this LDI instruction. Okay, what about R29? Can I use R29 with this instruction LDI? Boleh tak? Use the R29 for LDI instruction. Yes, you can use that. Okay, so now you see the difference between the lower register and upper register. Okay, every time you see the instruction that ended with I, so you need to make sure that you use the R16 to R31 only. Tak boleh guna from R0 to R15. Other than that instruction, you can use all the R0 until R31. R31. Okay, any question up until here? Okay, what is the difference between LD and LDI? So LD is load immediate, which is the data that you taken from outside the immediate data, while LD is the you load from memory space. Okay, one is the immediate value, the other one from pointer register. Okay, what we call here the indirect addressing mode, by using the indirect addressing mode. Okay, later you will learn more about this instruction LD. Okay, we have for the load itself, kita ada a few instruction. Kita ada LD, LDI, LDS, and LDD. Okay, later we will see more on this thing here. Okay, so in addition, okay, we'll still in the GPR. Kita masih lagi dalam GPR. In addition, GPR has 3 pointer register called a pointer register X, pointer register Y, and pointer register Z. Okay, tolong make a correction. Okay, so pointer register X is a combination of R27 and R26. Okay, so this is your SL. What is SL? Okay, X low, and this is R27 is XH. Okay, which is X high. Kenapa diperlukan dua general purpose register, dua GPR here? Why? Because pointer register, it is a 16-bit wide. Okay, your pointer register is 16-bit wide. Okay, since your general purpose register is only 8-bit wide, so in order to make it as a 16-bit wide, you need two general purpose register. Okay, so R27 and R26, okay, this is your pointer register X, while R28, R29, this is your pointer register Y, and R30 and R31, this is your pointer register Z. Okay, so what is the purpose of this pointer register? Okay, this pointer register serves as the pointer for indirect addressing modes. Okay, the one that you're going to use, the instruction that you're going to use is your LD tadi lah. Okay, indirect addressing mode. We have a few addressing mode. We have indirect addressing mode, direct addressing mode, and etc. Okay, so this one here, the addressing mode you will learn in the module 3. Okay, so to understand the purpose of the general purpose register, okay, so let's look at this example here. Okay, let's look at this LDI and ADD. Okay, so what the LDI do? Okay, LDI stand for load immediate data. Okay, so this LDI will copy 8-bit data into general purpose register. So this is the syntax. Okay, this is the syntax that I told you earlier. Okay, for the LDI, the syntax here is RD and then comma with K. RD is your destination register. Okay, so this is your destination register, while K is your immediate value. Okay, so since this is LDI, so RD, you need to use the RD between R16 and R31 only. What about K? What is the value of your K? Okay, the value of your K can be from 0 to 255. Ataupun in hexadecimal is from 0 to FF. Ataupun in binary from 0000 0, 0, 0, 0, 1, 1, 1, 1. Because it is 8-bit. Okay, ingat kita punya size is 8-bit. So that's why the value is up to 255 only. Ataupun FF in hexadecimal ataupun 111111 in binary. Okay, for example, let's do an example kat sini. Okay, you're going to load this value here, R25, to your R20 register. How to do that? Okay, so we recall back, this is our general purpose register. This is our data memory. Okay, can be divided into 3 parts. First is GPR, IO, and RAM. So now what you're going to do is here is, okay, this is your R20. This is your R20. So you're going to put value from outside, which is 25, and store it inside of your R20. Macam mana nak buat? How to do that? Okay, you have a 25. You're going to store inside of your R20. So in order to do that, we need to use the LDI instruction, because this is the immediate value, which is the value from the outside. Okay, outside of your memory means that an immediate value. Okay, you want to store to your R20, we need to use the LDI. So LDI. Okay, RD. What is your RD? R20. What about your K? The value lah. The K here, 25. Okay, OX 25. Okay, after you, what we call here, execute this instruction, automatically the R20 will have number 25 inside there. Okay. Any question? Let's say lah, I want to put number 100. This is decimal, yeah, because there are no signs here. Okay, OX means that this is hexadecimal number. Okay, sometimes you can put something like this. Load I R20 $25 pun equivalent. Okay, equivalent with this one. Sama. Okay, now I want to put 100 to my R70. How to do that? Okay, so you can use LDI. Okay, because 100 is your immediate value. You want to put inside of your R70. You just put LDI. What is the destination? R70. What is the value? Put hundreds. Okay, without any symbol. So you know that this is a decimal number. Ataupun, okay, LDI R17. Tukarkan, okay, you convert this 100 to hexadecimal number. What is the 100 to hexadecimal number? 64. Is it 64? Okay, sama, equivalent. Okay, so this is the load LDI instruction. Okay, to load a data ataupun to copy a 8-bit data to your GPR. Okay, next you're going to add instruction. Okay, to add the value from. Okay, so add instruction used to add the value from RR to RD and put the result back into your RD register. Okay, so this is the syntax: ADD, RD, RR. So RD is your destination register, RR is your source register. Okay, so what happened here is RD, after you execute this instruction, RD sama dengan RD plus with RR. Okay, the value, yeah, the value inside RD plus RR will be stored to your RD. Okay, contoh. We have contoh kat sini. You are going to add two number which is 25 and 34. How to do that? How to add these two number? Okay, because this is an immediate value, so you need to put this value to your GPR dulu. Okay, you need to put this value here to your GPR first. Okay, so let's lah this one you put to your R16, and this one you put to R17. Okay, so load I R16 OX25. So automatic R16 sekarang ni ada nombor 25. And then load I R17 to OX34. So automatic R17 now have 34 value. Okay, next. After that, you can use the add instruction. You cannot do ADD OX25 with OX34. Cannot. Why? Because the syntax says from register, add from register with another register. Okay, we need to follow this syntax. Kena follow syntax. Okay. Okay, once you finish, store this value here to your register, then you can add the value. So ADD R16 with R17. Okay, any question? Okay, this is the example lah of instruction that involve of the using of GPR. Ada soalan tak? Okay, if no question, next we'll go to the second part of our what we call here data memory, which is I/O register. Okay, the first one is GPR, and then followed by the I/O register. So what is the I/O register? Okay, the I/O register is dedicated to specific functions such as status register, timer, serial communication, I/O ports, ADC, and etc. So this is the involve of the specific any specific function will be any what we call here any data processing that involve of the specific function will be stored inside of your I/O register. Okay, the function of each I/O register location is fixed by the CPU designer. Okay, so you cannot relocate this I/O register location. Okay, because it's already been fixed. Okay, the number of location in the data memory set aside for I/O register depend on the pin numbers and peripheral functions supported by that chip. Okay, but all of the AVR have at least 64 byte of I/O register location called standard I/O register. Okay, so for Amiga 32, we have 64 I/O register. Ataupun sometimes we call it as a 64 byte I/O registers. Okay, so this is your example of the I/O registers. Okay. Okay. You see here, your I/O register kat sini, you have two addresses. Okay, one is for I/O addresses, the second one is memory addresses. Okay, later we will see the difference between I/O addresses and memory addresses. Okay, so this is the I/O lah, I/O register. Okay, yang selalu kita guna ialah the one that we always use in this course is this one here. Okay, so this is whenever you're going to use the ADC, analog to digital converter, and then okay, this one nampak tak ni, pin D, DDR-D, port D, pin C, DDR-C, port C sampai until here. Okay, this one when you use the input output port. Okay, every time you use the input output port, so you use this registers here. Okay, and then we have this one ya. Okay, yang ni this OCR2, TCNT2. Okay, all these things here. Okay, up until kat sini. Okay, this is for timer. And last but not least, this one here, TCNT0. Okay, this one used for interrupt programming. Okay, this is for timer programming. This is the register involved the timer programming. This is the register that will be that you're going to use when you write down your interrupt. And this is SPH and SPL. This is your for the stack. SRAC. Okay, this is the I/O register that you always use. Okay, this is your status register lah. Okay, and then another special register kat sini. Alright, so that is the I/O register that you need to know lah. Okay, and then okay, the second part is the I/O register, then followed by your RAM. Okay, so you have a GPR. Okay, this is your data memory. Ada GPR, 32 GPR, 64 I/O, and last but not least is your RAM. What is the size of your RAM? 2 kilobyte. Okay, so internal data SRAM widely used for storing data and parameters by AVR programmer and C compiler. Okay, each location of the RAM can be accessed directly by its address. Okay, you can access all the data inside of the RAM by using the address. Okay, so each location is 8-bit wide, can be used to store any data we want. Okay, so the size of this RAM is 8-bit. Okay, because your data memory is 8-bit, so the RAM also is 8-bit wide lah. Okay, and the size of your RAM can be vary from chip to chip. Okay, for ATmega 32, the size of RAM is 2 kilobyte. If you're going to use the ATmega 128, the size of RAM is 8 kilobyte. Okay, that's why you see here the RAM end, which is the last location of your RAM, the last address of your RAM is different from one chip to another chip. Okay, saya rasa this one is salah. Okay, later we'll need to figure out what is the value for this ATmega 128 punya ends, RAM end. Okay, so this is the overview lah. Okay, back your AVR architecture. Okay, this is your flash. You have the flash program memory, and then you have a data memory. Okay, you have 32 general purpose registers, 64 I/O, and 2 kilobyte of RAM, EEPROM, 1 kilobyte of EEPROM. Okay, now we're going to how to figure out this address here. Macam mana nak dapatkan this end address here? Okay, the last address of each of this memory here. Okay, to find this address, the last address of this memory. Okay, we're going to use the what we call here the formula. Okay, mana kita punya formula? Okay, the formula is end address equal to, okay, start address plus with your capacity, your size, ataupun capacity, okay, and then minus with 1. Okay, so this is the formula. Okay, you need to remember this formula lah. Okay, let's look at contoh kat sini. Okay, now we're going to find what is the end address of your EEPROM. Okay, so let's figure out what is the end address of our EEPROM for ATmega 32. Okay, so end address sama dengan what is the starting address of your EEPROM? Your starting address of your EEPROM is starting from 000 lah. So kamu 0000 plus capacity. Okay, what is your size? The capacity size of your EEPROM. What is the size of your EEPROM? Berapa dia punya size? 1 kilobyte. Minus with 1. You see, this 1 kilobyte minus with 1. Okay, which is sama dengan equivalent to 0000. Okay, 1 kilobyte, you tukarkan dia ke dalam, you convert it to decimal number equal to 1024. Okay, because 1 byte is 8-bit. Okay, so 1 kilobyte is 1024 minus with 1. Okay, so kamu akan dapat. Okay, remember this value here dalam hexadecimal, but this two value here is decimal. Okay, you need to convert lah. Okay, convert this value from decimal to hexadecimal, then Can you calculate it for me? What is the end address of our EEPROM? Dapat berapa kat situ? Okay, 0000 plus with 1024 minus 1. Okay, you get 1023. 1023 convert to hexadecimal, then what is the value that you get? Berapa kamu dapat? Ni one? Okay, 3FF. So you get 3FF. Okay, so that's how you get this value here. 3FF kat sini. Okay, so let's look at the RAM N. Okay, how to find out your RAM N? Sama juga lah. Okay, by using the same formula. What is your RAM N? Okay, start address. Okay, what is the start address of your RAM? What is your start address of your RAM in this case? Is it 0000? This is your RAM. Kat sini kamu punya RAM. So, what is your starting address of your RAM? Is it 0000 or number lain? Yes, the start address of your RAM is 0060. Kat sini. This is 0060. Okay, so 0060 plus with, what is the size of your RAM? 2 kilobyte minus with 1. Okay, so kamu akan dapat 60 plus with 2 kilobyte, 2 multiply with 1024 minus with 1. Okay, so 60 plus with 20, okay, this one, yeah. 2 multiply with 1024, you get 2048 minus with 1, convert to hexadecimal, kamu akan dapat berapa kat sini? Okay, this is hexadecimal, yeah, and this is the decimal. Okay, 7FF. Okay, 7FF. And 7FF plus with 60, you get 085F. Okay, so that is your RAM N. Kat situ. Okay, what about your flash? Program memory. Siapa nak tolong? For the program memory. Betul tak kamu dapat yang ni? 3FFFFF. 3FFF. By using the same formula. Yes. Please, somebody calculate your FN here, your last address of your flash memory. Okay, what is your starting address of your RAM? Flash program memory. 0000. And then plus with 32 kilobyte minus with 1. Betul ke sama? 0000. Okay. Kalau you do something like this, betul ke dapat this one? Is it dapat this 3FFFF? 000 plus 32 kilobyte minus 1. No, why? Why no? Kenapa tak dapat sama? Why you not getting the 3FFFF here? Okay, so sekarang ni. What is the size of your data memory? 8 bit. Betul tak? What is the size of your EEPROM? Also 8 bit. Now, what is the size of your program memory? Okay, 16 bit. So what are you going to do? Okay, 32 kilobyte minus 1 divided by 2. Okay, you need to divide it by 2. because it's a 16-bit, not 8-bit. Okay, and then you will get tambah di this one here, kamu akan dapat 16383, and then convert to hexadecimal, so you will get 3F, F, F, which is similar to this. Okay, so you need to remember this formula here. Okay, so if you're going to find, let's say lah, in the when for test here, they will ask you what is the end address of your ATmega 64, given that the size is 64 kilobyte. Okay, so you need to figure out how to calculate. Yeah. Okay, so Tan Wei Feng saying that, can he calculate that 8-bit for 1 kilobyte equal to 1024? Yes. How you get that? Okay, because 8-bit is 2 power of 8 actually. 2 power of 8, or 2 power of 8 you get 1024. Okay, that's why 1 kilobyte, which is ada calculator lah. Okay, so 1 kilobyte equal to 1024. Alright, next. Okay, earlier we saw the simple example using the LDI and ADD that use the immediate constant value of K and the GPRs. Meanwhile, the AVR also allows direct access to other locations in the data memories, such as RAM. Okay, instead of you get a data from your GPR, you also can get the data to other locations such as your RAM as well as your I/O register. So in this section, we will learn the instruction accesses various location of the data memory. Okay, so let's look at the data memory instruction, which is LDS. Okay, in this slide here, this is a LDS. LDS instruction stand for load direct from your data space. Means that you're going to load your data from your memory address. Okay, so this LDS instruction tells CPU to load or copy 1 byte from an address in the data memory to your GPR. Okay, so this is the syntax LDS RDK. Okay, RD is your general purpose register ataupun your destination register, while K, okay, this K here stand for your address. Okay, this is an address between 000 to FFF. Okay, in ATmega 32, the address here between 0000 to 085F. Okay, because this is your RAM add. Okay, so after the instruction is executed, the GPR will have the same value as the location in the data memory. Okay, for example here, you're going to load the R5 with the content of location address at 200. How to do that? Okay, so you just simply write down LDS R5 0x200. Okay, so dia macam ni lah. Okay, so I draw my data memory. Okay, this is my GPR, I/O, and this is my RAM. Okay, so this is my R20, for example. Okay, So next, since this is my RAM, so I know my static address of my RAM is 0060. Okay, so this location here, the data that I want to load is at location 200, which is somewhere around here lah, dalam RAM. Ada dalam RAM, which is somewhere around here. Okay, so I want to take the value from here, this location, and put to my R20. So how to do that? Using the LDS instruction. So LDS, bukan R20, sorry, not R20, R5. Okay, so we follow this example. So LDS R5, OX 200. What happened here is I go to address 200, take the value inside here, this address, and put to my R5. So my R5 now have the same value as the address 200. Okay. For another example, okay, you're going to add the content of location 300 to location 302. Okay, how to do that? Macam mana nak buat? Can I use ADD OX 300 with OX 302? Boleh tak macam ni? Is it valid or not? Not valid. Okay, because the ADD, okay, for the ADD instruction, you need to add between register with another register. So what you're going to do is you need to load lah. You need to load, okay, the content of this address to your GPR, and there's content of this address here to another GPR, and then after that you use the ADD instruction. Okay, so in this case here, because this is LDS, so LDS you can use lah any of your GPR starting from R0 to R31. So in this case here, I use the R0. Okay, LDS R0 OX 300. What happened is, so any value from any content from address 300, I put to my R0. LDS R1 OX 302. So content from address 302, I put to my R1, and then after that I add R1 with R0. So R1 plus R0, and then the result will be put or will be stored to my R1. Okay. So this is the lukisan lah. Okay, the summary of this example here. Okay. So mula-mula, I go to address 300, takes this value and store to my R0. Okay, and then I go to address 302, take another value and then store to my R1, and then I use the ADD to add both of that value. Okay, next we look at the STS instruction. Okay, so another instruction is called STS. So STS stands for store direct to data space, means that you're going to store the value to your RAM, to your memory. Okay, this instruction tells CPU to store or copy the content of the GPR to an address location in the data memory. So this is the syntax: STS KRR. RR is your source register, while KK is your memory location. Okay, so the K address between from 000 to FFF, but for the Omega32, the address here up until 085F only. Okay, so after the instruction is executed, the location in the data space will have the same value as GPR. Okay, so for example here, you're going to store the content of R25 to location 230. Okay, so saya lukis lagi sekali. So this is my R25 for example. Contohlah R25 ni ada nombor 0A. Okay, I'm going to store this value here to address 230. Okay, 230 is somewhere around here, for example. So that at 230, I have the same 0A value. So how to do that? Okay, I use the STS instruction. So STS, okay, where you want going to store? Dekat address ni OX230. What is the value? What is the content that you're going to store? The content is coming from R25, which is the content is 0A. Ada 0A inside R25. I want to store to address 230. So I use the STSOX230, R25. So automatically what happens is, after I execute this instruction, the value of 0A will be stored to my address 230. Address 230. Okay, so this is another example. Okay, I'm going to load the R60 register with a value 55 and then move this value around to IO register of port B, C, and port D. Okay, so what I'm going to do is, because this is the value okay, so this value is not inside the R16 yet, so this is an immediate value, so I need to load this value here so that it will be stored to my R16. And after that, by using the STS, I send this value to this address. Okay, STSOX38 R16, STSOX35 R16, and STSOX32 R16. Any question? Okay, so this is the instruction that when you're going to store or you are going to load from your RAM. Okay, so next instruction is how to move, how to store or how to load a data to your IO register. Okay, so to move to store, to load a data from IO or to IO register, we're going to use in and out instruction. Okay, so let's look at the in instruction first. So in stands for in from IO location. Instruction tells CPU to load 1 byte from IO register to GPR. Okay, so every time you use the in, it says that you want to load the data from your IO register masuk ke dalam GPR. Okay, so this is the syntax in RDA. Okay, so RD is your destination register, while A ialah IO location. Okay, which is your IO location address is from 0 to 63. Kenapa 0 to 63? Why is the IO location is 0 to 63? Because your IO register is 64, but you have 64 IO register, betul tak? So the address is starting from 0 to 63 only. Okay, so after the instruction is executed, the GPR will have the same value as IO register. So each location in IO memory has two addresses. Okay, as I said earlier, in IO memory, in IO register, you have two memory addresses. One is a data memory addresses, and the second one is IO addresses. So IO addresses is an address of each IO register in comparison of the beginning of the IO memory. Okay, so every time you use the in instruction, in and out instruction, okay, we will refer to IO address. Every time you use the LDS or STS instruction, okay, the CPU will look at the data memory address. Okay, for example, you're going to load R19 with the content of location OX10 of the IO memory. Okay, so macam mana nak buat? How to load the value from this location to R19. Okay, this address here is belong to IO memory. So to do that, you just simply write down in R19 with that at IO address OX10. So automatically, any value inside of this address will be stored to your R19. Okay, so as I mentioned earlier, okay, so inside of your I/O register, okay, so this is your data memory. Data memory can be divided into three parts. Okay, GPR, I/O, and RAM. Okay, so for the I/O RAM, you have two memory address actually. Okay, one is we call it as a memory address. The second one we call it as a I/O. Okay, every time you use the in and out, okay, you're going to refer to this address here, I/O address kat sini. Okay, every time you use the in and out, you need to refer to I/O address. Every time you use the LDS, STS, okay, you will refer to this memory address. Okay, so to work with the I/O register more easily, okay, we can use their name instead of their I/O addresses. Okay, contohlah, load R19 with the content of pin D. Okay, so you just simply write in R19 pin D. So you no longer need to remember what is the pin D punya address. Okay, so in this case here, the pin D address is 10. Okay, you no need to remember this pin address which is 10. Okay, just use the name instead of the address. Okay, so actually this one here, this is similar to this one lah. In R90 pin D, similar to in R19 OX 10. And this one here also similar to LDS, if you're using the LDS lah. R19. Okay, what is the value that I need to put here? Kat sini. Is it OX 10? Siapa nak tolong? Okay, so we need to refer lah to pin D. Mana kita punya pin D tadi? Where is my pin D? Okay, so this is my pin D. Okay, since I'm going to use the LDS, so I need to refer to memory address. What is the memory address? 30. Okay, so the value I need to put here is OX 30, which is all these instructions are doing the same thing. Benda yang sama. Okay. Okay, next, let's look at the out instruction. So this out instruction tells CPU to store GPR to the I/O registers. Okay, this is similar to STS lah, but for the out, we're looking at the I/O memory address. Okay, so this is the syntax. Out ARR. RR is your source register. A is your I/O address, which is your I/O address from 0 to 63. Your R can be from R0 to R31. Okay, after the instruction is executed, the I/O register will have the same value as GPR. So out instruction, the out register are referred by the I/O addresses. Okay, for example here, you're going to copy E6 to your SPL register. So how to do that? So first, we need to put this value here to our register. Okay, load I R20 to OX. Okay, OX E6. Okay, OX E6 you put to R20 and then send the value to your SPL by using the out SPL R20. Ataupun you can use out. Okay, if you not going to use the name, okay, you need to find out what is the I/O address for the SPL lah. For the SPL, okay, the I/O address for the SPL is 3D. Okay, so we just put the 083D with R20. Okay, ataupun you don't want to use the out instruction, you want to use the STS instruction. So STS, what is the value that I need to put here? OX berapa kat sini? Anyone? Okay, I want to send out this value here, E6 to my SPL. So if I'm going to use the STS instruction, what is the address that I need to refer to? Okay, 5D. Okay, so let's do another example. We have a lot of examples here. Okay, you're going to copy pin D to port A. Macam mana nak buat? Okay, first thing first, okay, you need to copy dulu lah. You need to get the value from pin D to your GPR. Okay, you cannot directly lah. You cannot directly copy this value and then send out to port A, for example. Cannot. Okay, you need to use the GPR, okay, to move that value. Okay, so in this case here, we use the in instruction, okay, which is we read the pin D punya value, put it to R0, and then from R0, we send it to our port A by using the out instruction. Okay, next we have the MOV instruction. So MOV instruction is used to copy data among the GPR register. Okay, so MOV hanya you only use when you want to copy the value from one register to another register. You cannot copy from GPR to IO register. Cannot. Okay, MOV only used for the among GPR register. Contohlah. Okay, you're going to copy the content of R20 and put to R10. So what you're going to do is move R10. So this is your destination register. R20 means that you're going to copy the value from R20 put to your R10. Okay, so this is what the MOV instruction do. Okay, any question? Ada soalan tak? There are more instruction involving the GPRs. Okay. Is there any question? Are you going to stop here or you want to continue? Okay, so we stop here. Okay, we continue in the next class. Alright, so if you don't have any question, okay, so I think we just we can stop here. Okay, for those who have yet to sign in the attendance, okay, tolong sign. Okay.